Aloha, Richard Halverson here. This is ITS128, and today's October 21st. And let me share my screen. All right. So October 21st might fall right here. Functions. Well, did we? Let's see how far we got last time. We got to 6.7. Coding functions. All right, let's go to 6.7. Oh, so we are in the function, so that's pretty good. Okay, let's go to the textbook. So I've created new instances of these textbooks where I'm actually able to add TAs, or teaching assistants. And so I added, and with teaching assistants, I can add certain capabilities. And so I've added myself as a teaching assistant who's unable to see anything but what the students can see, I think. Except for you probably don't have this. But I can't download anything else, can I? Oh, I can see how far people have gotten, I guess. But I'm not able to download any scores or anything else. All right, so good. So this is kind of like how yours is. We're going to turn this off. Sometimes when I record the background noise. All right, so we're in 6 and 6.7. Let's see what that was. Oh. Oh yeah, function stubs. I talked about function stubs last time, how you can just put those in there because when you're writing your code, you might want to do top down, or you don't code the details until you've coded the overall structure of the code. That is actually the better way to code. And this is showing you being able to raise an exception, but we haven't learned exceptions yet. All right, let's go to this next section. No, we did cover branches and loops, right? Coding function. We covered 6.7. All this says is that you can have branches and loops inside functions, of course. You can do anything you want inside a function. Everything is a function, really, because it's the operating system that calls your code like a function, and then your code's done and returns back to the operating system. All right, so functions are objects, which means you can pass them. Do we talk about bytecode here? Why do we have to talk about bytecode? And what's the relevance of this section here? I'm not sure. Yeah, I guess the main thing is that functions can be passed as arguments, and that's kind of unique to Python. Other languages, you can only pass data structures, data, as arguments. But Python and also JavaScript, also you can pass functions as arguments. But in most of the other languages you can't. But it's kind of a unique thing. So here, this is an example of where you ask the user, do you want to draw a monkey or do you want to draw a human? And if the choice is 1, that means the user wants to draw a monkey. So what it does is it passes the name of the function which draws the monkey head, which is this one. And print figure just receives as a parameter this function, and then it executes that function like that, because it's called face inside here. It's just called face. So it executes it, and then it prints out the body of the thing. So anyway, so you can pass functions as arguments. All right, so here's the output. The output of the following program is meow. Is it true or false? Okay, so so what it does is it sets this variable called print cat. We're assigning it this object, and this object is a function, and it's a function to print out the sound of a pig. Okay, so now because of this assignment, print cat really prints out the sound of a pig. So then we execute print cat, and it's going to execute print pig because print pig is set to that. I think that worked. I'm not used to okay, so I think what I said is true. Let's see if it's so the answer is false. Okay, it is false. The statement print cat equals print pig reassigns, that's a good word, reassigns the print pig function object to the variable print cat. The print cat the call to print cat thus calls the referenced object, which is equivalent to print pig. So once this assignment is made, this is no longer, this code is no longer even accessible. It's lost. All right, so our defined functions, then this returns a valid value. If this is a defined function and this is a defined function, no, I don't think this will work because we aren't using it. There should be print, there should be I don't think it makes sense. And then let's see, where is that up here? Yeah, okay. Okay, I'm going to say that I'm going to say false. Okay. Function objects don't support most operators. The minus, what sense does it make to add them? Oh, right, we're adding. Yeah, what sense does it make to add the objects? Now, if this produced something, if this produced a value, like a numerical value, and this produced a numerical value, the only way that would work is if you were calling them or, executing them. And the way to execute them is that you have to put the left, you have to make it look like this. You have to add this left, right paren like this, or like this. That executes the function. This just tries to add the two objects together. All right, anyway, so common errors. Wait a minute, didn't we talk about this? Okay, so this just talks about common errors that can be that you might make more than once, and so I guess it's something to look for if something is not working. Here's an example of you call a function called steps to feet, and pass in an argument, you could pass in the number of steps, and here's the function, but it doesn't return anything. There's no return statement. Okay, so that's a problem. If we're getting a return value from a function is a common error. I guess it is. Copying and pasting code can lead to common errors if all the necessary changes are not made in the pasted code. Okay, so what they're talking about here is, and you see me do this all the time, where if I'm going to write a new function, I just like find something that's close, copy, paste, and then I go in and make modifications to the changes. And here, for example, we have this function Celsius to Fahrenheit, and so we're going to make the reverse function. And so we got to do, first we have to subtract, well, we do the reverse function, and what we ended up doing was, we successfully did the reverse function. First we subtracted, the last thing we do is we add 32 to the temperature. So the first thing we do is we subtract 32 from the temperature, and then we multiplied the number by 9/5, and so here we multiplied the number by 5/9, which is the opposite, and then we get our result, and then we're done, and it's not working. Why? Because we forgot to do this last one. Here this has got to say Celsius. Did I do this one already? No. Using the Celsius to Kelvin function as a guide, create a new function, changing the name Kelvin to Celsius and modifying the function accordingly. All right, so we have Celsius to Kelvin, and we're supposed to make a Kelvin to Celsius. We have this one, and we're supposed to make this one. Oh, this is Kelvin, degrees Kelvin. Yeah, Kelvin is just like, all right, well, I guess it's just, you copy this and you paste it here, but instead of this, you have this, copy, paste, and I guess this should be value Kelvin instead of value Celsius. So I'm going to put this here. So this should be minus, let's get rid of this, and copy this there. So does this do the opposite? Let's see. This thing takes Celsius, adds 273 to it, returns Kelvin. This thing takes Kelvin, subtracts 273 degrees, returns Celsius. So I don't know, this will probably work. Scoping. Gosh, it just seems like we talked about this already. Do either of you know, do either of you recall my covering this in a lecture?
I don't.
You don't? Okay, well, maybe I'm just thinking of last semester or.
Yeah, I don't recall this either.
Good, good. When you get old, you got to be careful because sometimes your memory's not right. And so I got to ask you guys sometimes, but I think I've told you that I've done that before. I've forgotten to, now I regularly upload all my videos, but in the past, sometimes I wouldn't get to them right away. And I more than once, maybe only twice, but I actually just like start doing the lecture. It's the same one I did before. And then someone says something and I go, oh yeah, right. But anyway, so good. I'm glad this is new. Well, scoping is, maybe we just cover scoping two different places, but all right. So what scoping is you have, you're defining variables out here. Here you define a variable called centimeters per inch, and it's that. And then inside here, you also define variables inside of a function. Well, they're different. Even if they're the same name, they're different. And so if you want them to be the same, you have to actually say something. Yeah, you have to say global here. Okay, so here's an example. You have this variable called employee name, and you initialize it to n/a, and then you execute this program called, you execute this function called get name. That's the second thing you do. This is the first thing you do. Second thing you do is this, and so you go up here, and it asks the user an employee name, stores it here, and then it stores that into this variable called employee name. Okay, so this employee name is going to be different than this employee name. Because it's inside, it's scoped differently. It's scoped inside the function. In fact, when this function is done executing, it's all done executing, and we're down to here, then this variable's gone and this variable's gone, because this variable and this variable only exist when this function is executing. You know, it starts out, if they don't exist, then this function executes, they exist, and then it's done, and then the function's done, the function disappears. Because it's done, we're down here, and then anything inside did also. And so when we print employee name here, we're going to be printing this. Okay, well, that's probably not what you want. Probably what you want is over here, where you want this employee name to be this employee name. So when you print it, you know, this is outside the function. When you print this, you know, you're actually printing what was assigned here. And so the way to do that is you have to say, before you use it inside, you have to say, I'm going to be using this variable, and it's the variable that's outside. So don't make a new one. Just use the one that's out. And so then this will assign it to this. Okay, so that's a good example of scoping and global variables. And so here you see, this is what would happen if you execute it, because, well, wait, there's a different. Function definitions must be evaluated before the function is called. Oh, is that true? I mean, that's true in many languages, but it's also not true in many languages, because in many languages, the interpreter takes a pass through just to look for function definitions, and if there are, to make sure they're defined. So then like when you're writing, you know, you'll be writing JavaScript inside web pages, for web pages to manipulate the controls and stuff on, you know, on an HTML page. Okay, you'll learn that in 227 or in a class that probably in 148 you'll learn that. I'm moving more towards covering other languages in 148, not just Python. And JavaScript makes the most sense because you can just write JavaScript on your computer and then open it up in a browser, and the JavaScript will execute. You know, you don't have to, you know, use any kind of compiler or interpreter or download anything to execute JavaScript. But in JavaScript, you can use a function that's defined down below. You can define all your functions at the bottom of your file, at the bottom of the HTML file. So if somebody views a source, they have to scroll all the way down to the bottom to see your functions. But in Python, what they're saying is that before you can use that, the Python interpreter has to know what that is. And this is what tells the Python interpreter what that is. And so this has got to be up above. So that's why all the function definitions are at the top. It's not just for documentation purposes that you know what functions are coming, but it's because this actually has to execute. Okay, this executing creates the object, you know, gets the code there, and initializes or sets aside spaces for variables inside the object and so on. All right, so that's that. A local variable scope extends from a function definitions ending : a local variable scope extends from a function's definitions ending colon, okay, to the end of the function. Is that true? Well, it's actually yeah, okay, I'm going to say that's true. I think not from the colon, but rather the variables assignment. That's what I was just going to say. It's variables assignment. Global statement must be used to assign a global variable inside a function. To assign a global variable. Yes, that's true. Okay. A function definition must be evaluated by the interpreter before the function can be called. Yeah, that's what I was just talking about up here. So I think that's true. All right, namespaces and scope resolution. We just talked about this, didn't we? A namespace maps names to objects. Python interpreter uses namespaces to keep track of all the objects in the program. For example, when executing something like this, the interpreter looks in a namespace to find the value of the objects referenced by these two, by X and Y, and then evaluates the expression and then updates Z in the namespace with the expression's result. So here's an example of global namespace using the globals to get namespace names. Okay, so yeah, there's this function here provided called globals, and that produces a dictionary looking thing that contains the the variable name and its value. Yes. Or a variable name and it's the address of the object. Yes, okay, well, that's interesting. It's a namespace. So yeah, okay, it's a dictionary, right? This is the name of the function. This is the address of the function. This is the name of the variable. This is the value of the variable. All right, scope and scope. Scope is the area of code where the name is visible. Namespaces are used to make scope work. There are at least 3 nested scopes that are active at any point in a program's execution. There's the built-in scope, which contains like all the names that you can use in a Python program. You can use this, you can use this, you can use this. They're all there, and the names of those functions are defined. And then there's the global scope, which is just all your variables in your program. And then if you also have functions, then there's going to be local scope there, where inside the function there's going to be there's going to be namespaces, and then of course there can be functions inside of functions, and so there can be these nested namespaces. So there would be more than 3, or nesting. Okay, maps the visible names to in a scope. The area of code where a name is visible returns a dictionary of the names found in the local namespace. All right, I'm going to guess that's this. Process of searching namespaces for a name, that must be scope resolution. Resolving something. The area I'm gonna guess. All right, good. Okay. Okay, given the, I'll do the first one. Given the name, given the following program, select the namespace that each name would belong to. Okay, so player name, what namespace does player name belong to? Well, it belongs to the global. Doesn't belong to the local. So I'd say global. Role would be global, I think, because it's the name of it's an object. Number would be local, and str is built in because str is right here and here. Okay, anyway, more scoping and namespaces. The concept of scopes and namespaces helps to explain how multiple variables can share the same name, yet have different values. Okay, so this program first creates a variable temp in the global namespace, then creates another one in a local function. The assignment statement in this function creates a new variable within the function's local space. Then the function returns, the namespace is deleted. When the function returns, the function ends, the namespace is deleted. All right, let's see what we're supposed to be doing here. We're supposed to see. Wow. Use the term frame. You know why? Because it's also called a stack frame. All right, so we're executing this thing. It's gonna have a temporary variable inside. Okay, we said a equals, this is the first thing. A equals 5, b equals 10. I already got my points. Well, I guess I'm just gonna move on. I'm just kidding. And then we assign, we add them up. That thing gets 15, and then we're gonna print. Oh, we're gonna print whatever this is. This is the average of A and B. That's the first thing we're gonna print. And then the second thing we're going to print is this temp, okay? Unless temp were global here, and then in which case this variable would get overwritten, but it doesn't. Average of A and B figures out the average of A plus B, and it uses this variable temp. It's not this one, it's its own. So that's the point here. A namespace is how the Python interpreter restricts variables to a specific scope. I guess that would be true. Whenever a function is called, a local namespace is created for that function. Yeah, I guess that's true, unless it's a trick question. All right. Yeah, in other languages, you would say whenever a function is called, a new stack frame is created, or a new frame on the stack is created. If you ever take assembly language programming, if they let me teach ITS128 AL again someday, then we talk about that, and that's what happens inside your computer. All right, the same name cannot be in multiple namespaces. Yes, it can. That's false. If a programmer defines a function called this, the program will crash because there's already a built-in function with the same name. You know, the program, well, I don't think, I think it redefines, it actually redefines what this is. I bet it says right up here. So I'm just going to see what the answer is. I'm going to say no, but I'm probably wrong. User-defined function will likely be located in the global namespace. Since the global namespace is evaluated before the built-in namespace, the user-defined function will be called without issue. So in other words, you would be changing what that function is, and by doing that, you wouldn't have this function available anymore. You wouldn't have the built-in function available anymore. All right, anyway, let's see what's next. Function arguments. Of course, functions can have arguments. Talked about that. Here we're passing in an argument, adding one to it. What? Then what are we doing? Oh, here we're printing it. I got it. Can we do this? This is passed by assignment. I think what they're saying here is arguments to function are passed by object reference. When a function is called, new local variables are created in the function's local namespace by binding the names to the parameter. So what they're saying here is, well, let's see what happens, because I think what's going to happen is Timmy's age is going to print out as 7, because when this function is called, when birthday is called, this this is a new, I mean, this is going to be this, but this is going to be a new variable. It creates new variable, but actually, this comes in as a copy. When this is called, then whatever is here, a copy of it is created, and a variable name is created with that name. So a variable inside here is defined, and it's called age, and it starts out with the value that was passed into it. It starts out with that value, and then you can go ahead and manipulate it, but it's a new variable. It's a variable that only is local to this function, and once this function ends, that variable is gone. So unless you return something, changing this here is not going to change this here, which changes this here, which would mean that changes. That doesn't happen. And that's because it's immutable. Does it use that term, immutable? Yes, immutable. It's immutable. A mutable function would change. Okay, so if this were mutable, it's not, but if it were, then you change it down here, it's going to change it back up here again and change it here. Now, if you pass a list to a function, a list is passing a list to a function is mutable. The list is mutable. So if you were to manipulate the list inside here, if this were a list and you were to manipulate the list in here, then it would, lo and behold, manipulate this out here, and this would be the manipulated list. That was, but in this case, we're just passing a value. We're passing an integer, I guess. So it's immutable, so it doesn't change. It creates a new one inside the function. Here, this shows an example where it is mutable, right? Mutable. So here we're defining a list, 10, 20, 30, and then we're going to call this function called modify list. Comes in here. It's a new name, but it's the same list. New name, same list. And here we're going to change the index 1, the object, or the object in the list, the element of the list at index 1, which is this index. And we're going to put 99 in there instead. And so that's what this does. And so this puts 99 into this list, which is this list, which is this list, which is this list. And so this one is going to have the new 99 here. See, wait, yes, yeah, that's what happens here. And so when you click through this, that's what you see. Ah, so this is how you would do it if you didn't want what you sent to be mutable. If you just want to pass a copy of the list in, so when this thing happens, this is a different list. It's a list that's in the namespace of just this modify function. Then you do it this way. You put this on there, passing a copy of it. All right. What is this now? List argument modification. Okay. Address the fix me comments. Okay. So here we have an add grade. Okay, so this thing. Okay, so we start out by defining a dictionary called add student grades, and then we this is a prompt. This is just a string that we print out when we are asking them for something, and this is a prompt when they want to delete something. This is the menu prompt, and so okay, so and here we output the menu prompt. So in other words, we're going to output this whole thing, and we're going to that's the input string. That's the input function argument, which is a string that's displayed out, which prompts the user to type something. And so whatever the user types is going to be here, whatever the user typed in, and then we're going to make it lowercase, and then we're going to strip. I think this, what does this do? It strips the, what does strip do? Strip something. String functions. Strip returns a copy of the string with leading and trailing whites. Okay, so it's like trim. Okay. In other languages, that function is called trim. All right, so so whatever the user types in, it's gonna make it lowercase. Why would make it lowercase? The user is going to type in 1, 2, 3, 4, makes it lowercase, and then it strips off it if there's a space or an enter or something, white space or a tab, like before or after it, it'll strip that off. That's leading and trailing white space. So you get a clean, character, I guess. And so it looks at the command, and if the command is a 4, then we're exiting. So if the command is a 4, then this is going to be false, and it'll be done. Otherwise, if the command is not a 4, then if the command is a 1, it calls this one. Command is a 2, it calls this. Command is a 3, it calls this. And I guess what we're supposed to do is finish or write this function and write this function. Let's see. Is it worthwhile for me to do this? Sure. Why don't I do it? Well, I'm going to go over, and this will be my excuse to use the replit. And am I automatically logged in? I must be. These are mine. So I'm going to go to my REPLs, and I'm going to go into my test folder, and I'm going to create a new REPL, and I'm going to have it be this. And now what am I going to call? I'm going to call it 6-point list argument modification. So I'm going to copy all this. And I'm going to call it list 6.12.1. 6.12.1 list modification. List argument. That's good enough. Create this. And paste this. All right, so the first thing I have to do is create a delete name function. So student, okay, so I must have, okay, I've got a dictionary called student grades. And when I add something to student grade, I get something in here and I split it into, I get a name and a grade. And then I set the grade name equal to grade. Okay, and this is delete a name. Well, I'm just going to say it's def delete name parentheses this deletes it right here. Oh, all right, this is easier than I thought. I'm going to call it name, and I'm going to no, I'm not going to call it anything. I'm just supposed to take this cut, paste it here, and this thing is going to first print that, and I'm going to and this should just be this. And this also. This should be called print grades. And I should be print grades. And this should be there. And let me bring this in a little bit. Okay, so I think this might do it all. So let's run this, and I'm going to put a let's go over here to the debugger, and I'm going to put a breakpoint, I don't know, right here, I guess. I'll put a breakpoint right here. Why did that? Not there. I want to put it here. Okay, so so when this thing runs, it'll load up these objects, load up the whatever, so they can be used, and then it's gonna create an empty dictionary called student grades. It's gonna initialize this variable, set it to that, initialize this variable, set it to that, initialize this variable, set it to that, and it's gonna stop just before it executes the command. Okay, so I'm gonna run it, and I got an error. Let's see what the error is. Let's go to the very bottom, and we're on line 7, which is here. Define delete name. Oh, I forgot a colon. See, look at that, invalid syntax. So I'm going to put a colon there. And I guess I'm going to run it again. I guess run it again. Oh, got to put a colon there too. I should look at the little squigglies. Any more little squigglies? No. Okay, let's try this again. Boom. Okay, looks like we're sitting at 26, as you can see right here. Oh, look, 26, and we have a student grades dictionary. We've got a variable called menu prompt, which looks like this. We've got a variable called grade prompt, which looks like that. And we have a variable called delete prompt, which looks like that. Do we see like function variables? This is add grade. There's add grade, delete name, print grades. This is like the address of where these functions are, I guess. See, all these would be defined. This is an object. This is one. This is one. These 4 are ones. Okay, so now we're sitting at this and so let's execute this. Okay, well, let's just so let's step through this. I'm going to click next step, and it should be oh, it printed this out, and it's waiting for me to type something. So I'm going to type a 1. I'm going to type 1, enter. And so now I'm sitting right down here, and I'm on line 28, see right here. So let me next step, and the command is not equal to 4, so it goes down to this if statement, and it takes that if statement. You see, now it's on line 30, so now we're inside here. It's about to call add grade. So the next time I click it, we're going to be up here. And so I'm going to click it, and now we're up there, and we haven't executed line 2 yet. We're about to execute line 2, and when we execute line 2, we're going to see this says enter grade pop right out there. Execute line 2. There we go. Entering grade. Oh, okay. So it's asking me for a grade. Oh, it's asking me for a name and a grade. So I'm going to say we're at 3. 3 hasn't executed yet. So I guess I have to execute it first. And now it's asking me for Joe B. I'm going to give Joe a B. B. Enter. And then So now this statement is done executing because it got the input and it split it. And now we should have a variable called name and a variable called grade. And so that would be inside. Okay, here we got a variable called grade, and you notice it's B, and name is Joe. And but we must be inside. What happened to all the other variables? What happened to these ones that were defined down here? Well, they must be someplace. We'll see them again. Okay, so and now we're gonna set student grades equal to something. Let me just click again. And now we have where are we? We're at line 30. I thought we were. Okay, let me go to the next step. Okay, that was executed, it came back out again. Okay, and now we're, okay, so this finished executing it, and now we're down here, and we're asking for a new command. Now let me find student grades. Ah, here's student grades. Okay, Joe's got a B, so that was filled in. Joe got a B. So now we're going to ask for another prompt. We're sitting at line 39, and we're going to ask for another one. Next. We're sitting at 23. What happened to, do I have to type something? No, let's go again. What happened? Oh, it was waiting for me to enter in a command, and I didn't enter in a command, did I? So that means the command is just, it's just going to come down and ask me for another command, I guess. It's not that. It's not that. Oh, it's going to say unrecognized command. Unrecognized command. And now it's going to ask. Now it's sitting at 39. It's about to execute 39. Click. Now it's trying to execute 39. It's waiting for the input, and I'm going to say 4. I'm done testing this, so I'm going to say 4. Enter. And click. Why it doesn't show the, oh, was it waiting for something again? Oops, well, anyway, it's done. All right, so I didn't test everything. I just wanted to show you how to use that thing again. Well, anyway, okay, so it put in a B+ and C-, and I guess you should be able to see deleting. I guess you can delete. Okay, so basically what the point is that you create a list, you create a dictionary out here, and you're able to pass this dictionary to these functions in here. You're able to pass the dictionary into here. Wait a second. This isn't going to work. I got to pass the name of the function. I got to pass this in. Okay, I got to copy, paste. We should test this. Paste it in here because this has to be passed in here because that's how it knows where it is. If we were to run this, in fact, let's take this back out again. I gotta show you that there would be an error. So let's run this again. There's a breakpoint there. Let's do a break. Well, see, we don't have to do a break. I'm just gonna run this starting from here, and it's gonna ask me. It's waiting for a command. Sitting at 26, waiting for a command, and I'm gonna do. See, let me just do a 1. Enter. And then it's gonna, oh. Now it's sitting, oh, it's sitting here. Command is 1, so it says, okay, so the command did come in, and the command is 1, and so now it's gonna execute command 1. It's gonna go to add grades. Oh, shoot, this is gonna be student grades too. Can't edit. Yeah. Well, anyways, it's gonna fail. Well, let's see it fail. Let's see. Okay, so I'm gonna do let's see, did I do 1? Or is it, it's at, where is it? It's at oh, is it at 30? Oh no, it's up here. It's up here. Entering grade. Okay, did it say entering grade yet? No, not yet. Okay, now it says entering grade, and now it's sitting here, and it's about to execute, and I'm going to say Bob A+, even though we don't get pluses and minuses at KCC. Where's the plus? Enter. And then we can go more, and it's done. Comes down here, it's about to execute this. I go like once, and now it's waiting, and I do, I'm gonna do 3. I should get an error. Enter. Okay, so we see Bob A+ there, and we're sitting at 28 now, which is here, and it's a 3, so it's a 3, so it's gonna stop at here. It's gonna go here. It's gonna skip over that. It's at 3. It's going to go try to execute print grades. Now it's up here executing print grades, and it says printing grades, and then it's about to start this for loop, and it worked. It worked. Wonder why it worked. Oh, I guess it must it worked. So it somehow knew that the scope that this must be referring to this. That's interesting. Okay, well, let's keep on. So I'm going to try to delete now. Okay, so print grades. Oh, I only looked at it. I didn't delete. Well, let's see. Print grades. Okay, so I'm done printing the grades. Now it's ready to accept another command. Click, and I'm going to say delete. That's number 3, right? No, it's number 2. 2, enter. Why did I go down here? 2, enter. Okay, and so the command is 2. We're sitting at 29. Skips that in there, goes into delete name. We're up here now. It's going to print deleting grade, and oh, it's going to ask me for a name. It's about to execute this, and it says enter a name to delete, and I'm going to say Bob. Enter, and there's Bob. And so what's next? Boom. And delete name. And I guess the student grades, look, student grades is empty again. Okay, so I guess because it's okay, I guess it would be interesting to test this to see if we were to use a variable that was not immutable, not immutable. How about if I go test, stop this, test equals 10. Okay, I'm just going to put that there. And then I'm going to put in here, well, right in here, I'm going to say print test. This isn't going to work. Print test, I'm thinking it's this test. and see if this works. And I can just hit run. I'm going to take away this. And so if okay, I'm going to run, and I'm going to ask to do a 1. Oh, it did. It printed 10. Okay, so it must automatically, if it's not, if it can't find it in the local scope, it must look then must look globally for it. Anyway, so I'm going to confirm that, and I'll tell you next time. I'm going to look that up, see if it may just be, something about this particular system that goes and it just happens to look for one, and it's looking, and it finds the nearest test, and it happens to be the one that was previously defined globally. So anyway, how far did I get? I guess I got to section 612, which is only, I guess I got through a few sections. So I will see you next week. Are there any questions? Are we gonna do this thing on tomorrow? You want to do the?
Is that the Saturday? You okay with it?
Yeah, Saturday. Oh, that was Saturday. Today's Thursday. Today Thursday.
Are you gonna have class tomorrow too, or no?
Pardon?
You already had your second class for the week, yeah?
Yeah. This is my third. Yeah. In fact, didn't we have 3 this week? Yeah. So, but do you still want to have our study session on Saturday at 1 o'clock?
Are you okay with it?
Yeah, fine. I'm great. Yeah.
Yes, please.
Let's do it.
Because I like to use that Saturday to review and then ask you questions of what we learned this week.
Very good. Okay.
Any other questions? Thank you so much.
Okay. I'll see you Saturday at 1.
Saturday at 1. Yes.
Yeah.
Thank you.
Thank you. You guys.